Hi, welcome back. In this video, we'll be discussing level 2 questions on factorization. Level 1 was easy, and right now we are on level 2, and after this we'll be doing level 3 questions. Having said that, let's start with the video. Let's start with the mid-level questions. The first one is an interesting problem. Here, when I look at the question, I notice that 1 by 4x square can also be written as 1 by 2x whole square plus 1 as it is, and if I take 7 common from the last two terms, I will get 1 plus 1 by 2x. Let x plus 1 by 2x be equal to a. If I square both sides, I will get a square plus b square plus 2ab, and that is equal to a square. Here 2x and 2x will get cancelled out, and we will be left with x square plus 1 by 4x square, that is equal to a square minus 1. Now let's replace them in the given question. So the first two terms can be replaced by a square minus 1, plus 1 remains as it is, and the last term, last bracket, is a. So the given equation can be written like this. This plus 1 and this minus 1 will get cancelled out, and we will be left with a square minus 7a, which can also be written as a into a minus 7. So let's replace a back as x plus 1 by 2x, and we'll get our answer. So this is the factorized form. Let's look at question number 2. This is pretty much the same as the first question. Here I notice that 9a square can be written as 3a whole square, and 1 by 9a square can be written as 1 by 3a whole square. Let's see if we can get other factors. Minus 2 as it is, and if I take here 4 common, we'll be left with 3a minus 1 by 3a, and that's it. Here we got our substitution. Let 3a minus 1 by 3a be equal to new variable y. If I square both sides, I'll get 9a square plus 1 by 9a square minus 2 into 3a into 1 by 3a. 3a gets cancelled out. We can shift this 2 to the other side. So we'll get 9a square plus 1 by 9a square is equal to y square plus 2. Let's replace this in the given question. So the first two terms can be replaced by y square plus 2, minus 2 as it is, minus 4 times we can write y. Therefore the given expression will convert to y square minus 4y, which we can write y into y minus 4. Now we can replace y as 3a minus 1 by 3a. So this is the final answer. So first and second are pretty much the same type of question. Let's look at question number 3. In this question, I notice that if I take 4 common from the second and the third term, then I will generate 2x minus 3y. Now we can easily take 2x minus 3y as a, so we'll get a quadratic equation which looks like this. Now we'll use factorization method. We'll take the product of these two extreme terms, which is 12, and write the factors in such a way that the sum or difference will generate 4. So if I do 2 and 6, that will generate 4. So we can safely write minus 6a plus 2a minus 3. If I take common, this is what I'll get. So the equation will be factorized into 2a plus 1 into 2a minus 3. Now in the final step, let's replace a with 2x minus 3y. So we'll get 2 times this. Therefore the final answer can be written as hope this is clear. Let's try question number 4. The first thing that I notice here is that it somehow matches with a cube minus 3a square b plus 3ab square plus b cube, something like that. I notice that there are alternate plus minus signs also. Here we are using a formula of a minus b whole cube, which is a cube minus 3a square b plus 3ab square minus b cube. So let's write 27x cube as 3x whole cube. Now here I have to write 3x whole square. Now let's see what we can write here. So this is 9 and 3, 27. This part is 27, but we want 54, and also we want y term. So I am going to multiply with 2y. Let's see if it matches with other terms also. Next is 3x into 2y whole square. According to the formula, this is what we should write. Let's see, does it match? So this is 3 into 3 is 9, 9 into 4 is 36, xy square. Yes, it is matching with this portion. Next, we should get 2y whole cube. But 2y whole cube is not present in the question. So I am going to add 2y whole cube and minus 7y cube as it is, no change. Notice, in order to balance minus 2y cube, I added 2y cube. Now we can combine the first 4 terms and we can write it as 3x minus 2y whole cube according to the formula, and then we are left with 8 minus 7, which is plus 1, so we will get this. Now I am going to apply the formula for a cube plus b cube. A cube plus b cube is a plus b into a square minus ab plus b square. So let's apply this formula. Here a plus b means 3x minus 2y plus y, a square means 3x minus 2y whole square minus ab 3x minus 2y into y plus b square. This we can simplify and write it as I applied a minus b whole square and I expand it like this. If I open all the brackets, we can write this equation as therefore the most simplified form will be this is the final answer. Now let's look at question number 5. I notice that the first 3 terms can be factorized separately. Let's see. By splitting the middle term method, let's split the first 3 terms. I am going to write it as minus 5ab plus ab minus b square, and the last 2 terms I see 7 common, so I have taken 7 out. Here we'll get a minus b, here also we'll get a minus b. Therefore from the entire equation we can take a minus b out and we'll be left with 5a plus b plus 7. So that will be the answer. Easy? Alright, let's start with question number 6. Does it look scary? But nothing is there in this question. Let's see. I notice there is ax term, there is az term, and then there is ay term. So let's collect all the a's together. So we'll get x plus y plus z. Similarly, if I collect all the b's, I'll be left with y plus x plus z. That's it. We can take x plus y plus z common. We'll be left with x plus y plus z into a plus b. That is the answer. Easy. Let's try question number 7. This one, also by inspection, we notice that x minus y whole square is present here. Here also I can take common and we'll get x minus y, and here also I will get x minus y. So let's take common x minus y whole square plus q times x minus y plus 3 times x minus y. If I take x minus y common, we'll get p times x minus y plus q plus 3. And that's it. This is the answer. This is the most simplified form. Let's try question number 8 now. We have already done similar type of questions. This is clearly given 2x minus 3y, 2x minus 3y. So let's start by taking 2x minus 3y as a new variable, let's say a. Therefore the equation converts to 10a minus 8a square. In order to factorize it, I'll use splitting the middle term. I'll take the product of these two terms, which is 56. I factorize it, so we'll get 14 and 4. Yes, 14 and 4 give us 10. Therefore I can write 7 plus 14a minus 4a minus 8a square. We can take common, so 1 plus 2a will come common. Similarly, in the last two terms, 4a if I take common, I will get 1 plus 2a again. Therefore final factorized form is this. Therefore the factorized form will be something like this. Let's replace a by 2x minus 3y in each of the brackets, and this will give us the final answer. This is the final factorized form. Let's try question number 9. Here we notice that y square minus 2y is common in the first two terms, and the third term is y minus 2. So let's see if we can take something common. So I'll take one y out, so I'll be left with y minus 2. I will take another y common from the second term, so we'll get 2 minus y. And in the last term, I can take minus sign out, so I'll get 2 minus y. Now we can easily take y minus 2 outside. We will be left with y square minus 2y and plus 1. This is super easy. This is a perfect square, a square minus 2ab plus b square. We can write it as a minus b whole square. So this is the final answer. Let's try question number 10. Here I notice that a square is a perfect square. 9b square can be written as 3b whole square, and 6ab can be written as 2a into 3b. Therefore the first three terms can be converted using the formula of a plus b whole square. We can write this as a plus 3b whole square minus 49 can be written as 7 square. We will apply the formula a square minus b square. We know that a square minus b square is a plus b into a minus b. Therefore, we can write this as a plus 3b minus 7 into a plus 3b plus 7. This is the final factorized form. That's the answer. Question number 11. 11 is similar to the question that we did earlier. I can write 4a square as 2a whole square. I can write 25b square as 5b whole square. And the middle term, let's see if it works. 4 into 5, yes, 20. It is matching with this. Therefore, the first three terms can be written as a perfect square, 2a minus 5b whole square minus 100. We used a minus b whole square to write the second step. And now we will be using a square minus b square to write the next step. 100 can be written as 10 square. So therefore, we can write this as 2a minus 5b whole square minus 10 square, which can be factorized as 2a minus 5b minus 10 into 2a minus 5b plus 10. That is the final answer. Now let's try question number 12. Oh my god, this looks pretty complicated. There are so many terms here, but we will not lose patience. Let's see if we can factorize these three terms. First is 2a whole square, that is easy. This is 3b whole square, this is straightforward. Can we write the middle term as 2ab? Let's see. So we notice that 4a whole square can be written as 2a square, 9b square can be written as 3b whole square, and the middle term can be written as 2 into 2a into 3b. Therefore, these three terms are easily factorizable. If I take minus common, we have 9p square, which can be written as 3p whole square. Then we have 16q square minus 16q square, So basically I can write like this. Now we notice that the first three terms can be combined and written as 2a plus 3b whole square minus, whereas the last three terms can be written like this. Therefore, applying the formula of a plus b whole square, we can easily write like this. Now here again we apply two formulas, one is a plus b whole square and other is a square minus b square. Therefore the final answer is 2a plus 3b plus 3p plus 4q multiplied by 2a plus 3b minus 3p minus 4q. So this is the final answer. Let's look at question number 13. Oh, this one is a tricky question. We notice that 8x cube is written, 8x square is written, but there is no x term. And then we have final 9. I could have started with perfect cube, but then some terms are missing. Let's see what we can do. Can I split it and write 8x square as this? You notice that minus 12 plus 4 is minus 8 again, correct? Now I can take common. In the first two terms, if I take common, then I'll get 4x square will be left with 2x minus 3. Similarly, in the last two terms, I expand using a plus b into a minus b. Now I take common, so we'll get 2x minus 3, 4x square plus 2x plus 3. So that is the final answer. So the trick only here is to identify that minus 8x square can be written as minus 12x square plus 4x square. Once that is done, the rest is super easy. Let's look at question number 14. Oh my god, it doesn't look like it's even factorizable. There's nothing more to factorize here. If it was a minus sign, then we could have factorized it. But the plus sign is in between. What to do? Let's see. I can write x square whole square like this. Now we also have 2 square. I'm trying to match with either a plus b whole square or a minus b whole square. If that is the case, then I would write 2 into x square, 4x square, and I subtract 4x square. These three terms combined together will become x square plus 2 whole square, and then the last term can be written as 2x whole square. Now it's easy. What we are observing here is a square minus b square. We know that a square minus b square is a plus b into a minus b. So that is the final answer. The formulas used in this question are a plus b whole square and a square minus b square. It doesn't look like factorizable from the outside, but when we add and subtract one term, then it is easily factorizable. Let's look at 15, which is quite similar to 14. Again, I have 4x raised to the power 4, which can be written as 2x square whole square, and then we already have 1. So in between we can have 2x square. I similarly subtract 4x square. Because I have added 4x square, I am subtracting 4x square. The first three terms can be combined and written as a perfect square, and 4x square can be written as 2x whole square. Now again I will apply the formula of a square minus b square. So answer will be 2x square plus 1 minus 2x into 2x square plus 1 plus 2x. That is the final answer. If these terms are also factorizable, we will factorize it, otherwise we will leave it as it is. Let's apply the same concept on 16th. Here 14x4 is written, which I can write 2x square whole square, and then we have y square whole square. If I want to apply the formula of a plus b whole square, I will be needing 2 times 2x square into y square, which is 4x square y square. So I added and I subtracted 4x square y square. Now I can combine the first three terms and write easily as 2x square plus y square whole square minus 2xy whole square. This can be factorized into minus 2xy into so that is the final answer. Again, the formula used are a plus b whole square and other is a square minus b square. Next is question number 17. Here I notice x raised to the power 4 and x square. We can write x square as a new variable, suppose t. Therefore, the equation converts to t square plus 8t minus 9, which is equal to t square plus 9t minus t minus 9. I can take t common, so we will get t plus 9. Therefore, the final answer will be t minus 1 into t plus 9. But the question is not in terms of t but in terms of x. So I replace t with x square, which can further be factorized into x minus 1 into x plus 1 into x square plus 9. That is the final answer. Here we use the factorization method, splitting the middle term, and we applied the formula a square minus b square. 18th is a similar question to 17. Here again I will take x square as new variable t. Therefore, this becomes t square minus 5t minus 36. Now we will use splitting the middle term. I will write all the factors of 36. We will take product of the coefficients of t square and the constant term, which is 36. 2 times this will be 9. I can combine 9 and 4 to get 5. So therefore we will write t square minus 9t plus 4t minus 36. T common, t minus 9, 4 common, t minus 9. The final answer will be t plus 4 into t minus 9. Now we will replace t with x square. So we will get x square plus 4 into x square minus 9. This can further be factorized into x minus 3 into x plus 3 using the formula a square minus b square. So this is the final answer. 19th is also similar to 18th. Here I notice x cube is there, x6 is there. So let's take x cube as new variable t. Therefore, the equation will convert to t square plus 11t plus 24. Can we factorize this by splitting the middle term? So 24 means 2 into 12, which can further be written as 2 into 6. So 4 and 6 will not give us 11. I'll do one more time. Now we have 8 and 3. 8 plus 3 is 11. So therefore, we can factorize 11t as 8t plus 3t plus 24. T common, t plus 8 plus 3 common, t plus 8 will get t is x cube plus 3 and this is x cube plus 8. We can leave the answer here itself, or we can further factorize it using a cube plus b cube. We know that a cube plus b cube is a plus b into a square minus ab plus b square. So we will go one more step down and we write the final answer as x plus 2. 8 is 2 cube, so I can write x plus 2 into a square minus ab plus b square. So this is the final factorized form. If you want, you can factorize this also, or you can leave it as it is. And now we come to the final question. This is pretty straightforward. I notice 5 and 10. So if I take 5, then I'll get 1 minus 2. Here also 4 is common. If I take 4 common, then I'll get 1 minus 2. So I think we can take common in the first two terms. I am taking common. 5x square is common, so x minus 2 will be left. In the last two terms again, 4 is common, I take out, so therefore x minus 2 will be left. Therefore the final answer will be x minus 2 into 5x square plus 4. That is the final answer. This was pretty straightforward. Hope you found these questions interesting. Congratulations, you have finished level 2 questions on factorization. Now is the time for level 3 questions. Let's see if you can do those questions also. So try these questions and I'll see you in the next video.